Hello everyone, my name is Waffle and welcome to the 10th episode of Strats Explained, Magically Easy, a video series where I explain how and why different strats and glitches that speedrunners use work. Today is a special episode because we are finally going to talk about how duping and insta-passing works. The poll was kind of a joke, but it had an actual purpose. If you want to know about it, you'll have to read the original post on the community tab. The topic is hard, you'll have to listen very carefully. But we'll start from the very beginning and I'll try to illustrate everything I talk about. I'll break the explanation into multiple parts. You don't have to watch all of them in one sitting. You can find all of the relevant timecodes in the description. Before we start, I'd like to discuss the importance of this episode. Having this topic covered allows me to explain other related and interesting topics in the future. So if you truly want to understand how some of the strats work, you'll have to understand this one first, sooner or later. Let's begin with two questions. What is duping and how is it useful? Duping is starting a mission while another one is already active. Of course it can be the same mission, but then the result is kind of boring. Most of the time you just get duped objects. But even that has a useful application in speedrunning. I have a whole episode dedicated to the strat and you can find the link both in the card right now and in the description. But the real fun time begins when you start one mission during a completely different mission. Unfortunately, if you do that, there is a very high chance of the game crashing. If the game doesn't crash, there is still a decent chance that one of the missions is going to fail. This sometimes can be used to obtain special vehicles, or in this video I'm opening the laundry doors and therefore making my save file more unique by adding a special property to it if you want. Of course, speedrunners don't really use it that much. But sometimes when you start a mission, it immediately passes. We call it an insta-pass. In this particular example, we insta-passed the taxi driver mission. Now we don't have to drive 100 passengers to their destinations, which is pretty damn fast if you ask me, especially if you're speedrunning 100%. Everything I'm going to talk about today also applies to GTA Vice City, San Andreas, Liberty City Stories and Vice City Stories. Younger games have some nuances, but we are not going to pay attention to them. I would also like to mention that an insta-pass doesn't mean that you get the big "Mission Passed" text on the screen. In fact, another insta-pass just happened on your screen, and I bet some of you didn't even notice it. I will explain what is going on a little bit later. The very first thing we need to do is we need to learn how to read the script. And the easiest way of doing so is by reading the source code. Source code is literally what developers wrote. Of course it's a confidential information, but thanks to the mobile version of GTA 3 and later to Definitive Edition, we have access to the source code of GTA 3, Vice City and San Andreas. What is a script? Script is basically a bunch of commands. One line, one command. Most of them are very self-explanatory, so let's try to read it. We'll start from here. Create pickup with ammo, weapon Colt 45, which is a pistol, pick up once, 45 rounds, and we want to create it at these coordinates. Then we save it into GunChunky. GunChunky is a variable that we can use later to refer to our create pickup. Next we add sprite blip for pickup for our GunChunky pickup, and we want it to be Raider sprite weapon, so on our minimap we'll get this little weapon icon. Next we create an object, Noodles box at these coordinates and we save it into Noodles stand. Create car, car perennial, at these coordinates, save it into Chunky's car. As you can see, very easy to read. And the very first analogy I want to make is that reading a script is very similar to reading a book. You read a book line by line from top to bottom. And you read a script command by command from top to bottom as well. The only difference I can tell is that here each command is located on its own line. And in books, sentences usually go one after another, but it doesn't make it any different. In case you don't understand what command is doing, don't worry. There are only a handful of commands you need to know in order to understand how duping and insta-passing works. And let me introduce you the very first one. If I scroll a little further, we'll see this while and end while pair. This is a loop. A loop basically means the following. As soon as we enter it, we continue executing it from top to bottom, just as before, but when we get to the very end of it, instead of continuing reading it from here, we go back to the very first line inside of the loop and read everything again, and then again, and then again, and we do that while the condition is true. condition is located next to the while keyword, and in our case it's that. It basically means that while our player is far away from Chunky, because you see locate player any means char 3D, and there is not in front. So while we are far away from Chunky, we execute everything that's inside. As soon as we get close to Chunky, we break out of the loop and continue executing from here. There are a lot of loops in this game. If I scroll back, we'll see that there is another one. Before it, we request some models, and then we say while not has special character loaded, or not has model loaded pet gang triad A, or not has model loaded car perennial. So while at least one of these three models is not loaded, we are looping, because we want all of these models to be loaded. Why? Well, if you try to spawn something before the model for it is loaded, the game is going to crash. So it's very crucial to load all of the models first. And what's interesting about this loop is that it has three conditions, and they are joined by OR. The next command we need to know is located right here. If it's char.that Chunky, then we want to go to mission joy to past. Mission joy to past is a label we want to go to. So what does it mean? In our particular example, in this mission, we don't care when Chunky dies. If he dies, even if we don't get close to him, we want to pass the mission. So we want to go to the mission passing sequence. And this sequence starts by this label. Generally, it can be located before the goto command, or it can be located after the goto command. In our example, it is actually located after. Let me tell you where it is. It's right here. And when we go there, we continue executing from there. So after this label. First we play music, then we print the big text on the screen, then we clear our wanted level, add money, etc, etc, etc. I want to briefly go back to the book analogy. Imagine that you want to become a magician and you're just starting out. So you got this brand new book that explains tons of cool tricks. You open the table of contents and start reading it line by line. And you realize, oh wait, you actually know the first trick, and the second one, and the third one. So you continue reading until you find something new, something that you're interested in. And then you see that it is located on page 19. 19 in this case is a label. So you want to open page 19. You want to go to page 19. You want to go to label. And then you continue reading from top to bottom, just like a normal book, just like a script. There is another important command that we need to know. It is very similar to goto, and it's called goSub. Once again, we get a label. It can be located before and after the command, and just like with goto, we actually jump to that label, execute everything that is located here line by line, but in the very end, we always hit a return, because goSubs and returns come in pairs. And when we hit a return, instead of continuing reading from here, we actually go back to where we started and continue reading from there. And once again, table of contents is a perfect example, because we find the trick that we're interested in, we jump to that trick, we read everything that is here, the whole description, and when we're done, we want to go back to the table of contents to see if there's anything else that we can read. So we continue reading from the next trick, line by line. The last thing that we need to talk about is branching with if, else, and if. Just like with the while, we have a condition, and if that condition is true, then we execute everything that's located inside of the first branch, in this example only one command. Otherwise, or else, we execute everything that's located inside of the other branch. So an if-else statement guarantees you that only one of these two branches is going to be executed. It's also worth mentioning that the else part might not exist at all, just like in this example. Here, if the condition is true, then we execute the code inside of the branch. Otherwise, if the condition is false, we don't execute anything at all. And that's basically everything you need to know in order to be able to follow the flow of the script, to understand where it goes at every given point of time, and to understand what is going on in general to a certain degree. Alright, let's move on. What we have on the left is written by developers, and it's meant to be read by people. The game cannot understand it. What it actually needs is a file called main.scm, and it looks like this. A bunch of seemingly random hexadecimal digits. There is no way we can read it, but the game actually can. Just so you can compare, here's how we create a pistol here, and that's how we do it there. Unfortunately, when the game just came out, we had access only to this file on the right. But luckily we don't have to understand how to read it, because smart people figured it out for us, and they created a program that converts this file on the right into a text file that looks similar to what we have on the left. And this is the next thing we're going to look at. And there it is. Let's compare it to the source code. The very first thing we see is that there are 3 additional columns. Don't pay attention to them yet. I'm going to explain what they mean later. Next, what you will not see on the right are lines that start with double slashes. These are comments and they get deleted during the compilation process. We can assume that back in the day developers thought that it is a good idea to lock car doors for chunky cars, but then they decided maybe not, and commented these lines out, so they don't get into the final game. Also, some of the comments are not even commands at all. Start of mission is just a comment. What stayed unchanged, however, is the way we read the script. It's still from top to bottom, line by line, command by command. But there are other differences, and mainly in the names of commands and variables. Here we have create pickup with ammo, and here we create weapon pickup. Here we have a variable called gunchunky and it's located at the end of the line, and here it is called Joey2 Colt 45 pickup and it's located at the start. As you can see, things are called differently, but they still do exactly the same thing. And it's not that hard to understand what they do either. I should say that it is possible to generate the file on the right in a way that it looks exactly the same as the one on the left, but most people tend not to. Why? I think because they are too lazy to do so. And, as I said, it's not that hard to read the one on the right anyway, and that's why we have to understand how to read it, because if you ask for a decompiled version of the script, you will most likely get something that looks like the file on the right, not on the left. Another thing that stayed unchanged and works exactly the same way as I explained before is a goto. We have a goto and we have a label, and we jump to that label. But what you'll see is that we have a lot of labels here. We don't have them on the left. And why is that? Well, the answer is very simple. If I scroll a little bit further back to the while loop that we already saw, and I do the same here, we'll see that we don't have a while and end while keywords there. We have only an if, goto, and goto if false. Goto if false is the same as goto, but it always has a condition before it, and if that condition is false, then we jump to the label. If that condition is true, then we ignore the goto completely and just continue normally. So in this case, if all of the models are already loaded, we don't have to load anything else, the condition returns false, and we go to that label and continue executing stuff normally. But if at least one model is still loading, then we skip the goto if false, go here, go to Joey2 1004 and jump to 1004. And that is basically how we go on to the next iteration. Go subs and returns are still there and they work exactly as before. Here's the first and the second one on the right, and there they are on the left. What we don't have on the right though are elses and ifs. Instead we have, you guessed it, if, goto and goto if false. These 3 commands are enough to implement the whole looping and branching logic, so we don't need anything extra. So let's quickly summarize this part. Everything is almost exactly the same as before. Yes, we got new names for commands and variables, but you shouldn't be scared if you see a jump command instead of a goto command. You can always realize what it does, and if you can't, you can always go back to the source code and see the real name. We also don't see some of the old commands, instead we have if, goto and goto if false, and that's enough for us. Did it become harder to read? Well, I would honestly say no, just a little more inconvenient. But that problem goes away with time, with experience, because the longer you read it, the easier it becomes to read in the future. It is time we talk about the first 3 columns. I'm going to start with the last one because it's the least interesting one. Here we just see the hexadecimal numbers that we already saw in main.scm, and that's about it. We don't need to understand them and we don't need to use them. To explain the first 2 columns, I'm going to use a little example that I prepared for you. Here I have a few poems, and let me explain how these numbers are calculated. Pay attention. If I select the first line, we'll see that I selected 32 characters. So we write 32. I select the next one. 30 characters. 32 plus 30 is 62. The next one. 33 characters. 62 plus 33 is 95. And so on. So this number shows how many characters were already written before that current line. And for the first line, it's obviously 0, there are no lines before it. The second line, well, it's 32. The next one, 62, etc. The difference between these two columns is the following. If we look at the first one, we'll see that the number is growing and growing and growing until the very end. But the second one grows until we hit the next poem. And when that happens, we reset it back to 0. I select the first line, it's 14 characters long, so 14 is there, and 355 plus 14 is 369. So nothing has changed in our calculations. We just have to reset the second column when we start a new poem. And exactly the same thing happens with scripts. The number in the first column increases until the very end, and the number in the second column increases until the end of the current script, and then resets to 0. The number in the first column is called a global offset, and offset from the start of the file. The number in the second column is called a local offset, an offset from the start of the script, and we're going to be using that number a lot. Of course, here it's measured not in characters but in bytes, but we don't care about it. It can be measured in kilograms even. We only care about the number itself. But why is it so important? As you know, a GTA game has a lot of scripts. A script that is responsible for unique stun jumps, a script that is responsible for hidden packages, for rampages, for each mission obviously, etc. And a lot of these scripts are active at the same time, so you can complete a unique stun jump or collect a hidden package or even buy a gun in ammunition during a mission. Of course, these scripts are not processed in parallel, this game is just too old for that. So these scripts are processed in a sequence, one after another. And the question is, how does the game understand that it's time to stop processing this script and it's time to start processing the next one? The answer is, there is one more command that I didn't explain earlier, and it's called wait. So what happens is the following. We process the script line by line and hit the wait command. Then the script literally waits the number of times that is specified as an argument. In this example, 500 milliseconds, so half a second. When we hit the wait command, we move on to the next script and start processing it until we hit a wait command there. Then we move on to the next one and the next one until we process the very last one. Then we go back to the first one, so to this one, and the game asks a question. Have 500 milliseconds elapsed? If the answer is no, then we skip the script and go to the next one immediately. If the answer is yes, then we continue executing commands from this script until we hit the next wait command. In this example, 0. 0 means don't wait at all. So wait 0 is just an indicator that tells the game that it's time to stop processing this script and it's time to go to the next one. But as soon as we go back to this one, we are going to continue executing stuff from here, because obviously 0 seconds will have passed by then. If these wait 0 commands weren't there, then the game would just get into an infinite loop and freeze. Alright, next question. How does the game know where from it needs to continue processing the current script? And this is where the local offsets come into play. Each script remembers the local offset of the next command it needs to execute. So in this case, when we hit this wait 0, the script remembers that the local offset of the next command is 1031. So when we go back to processing this script, we continue processing it from 1031, from go to joy to 1004. And that's basically it. One more thing, however. As you know, there are a lot of missions in GTA, but at any given point in time, at most only one should be active. So keeping all of the scripts for all of the missions in memory is very inefficient and wasteful. What the game does instead is the following. It has a special place in the memory, so when you start a mission, it loads the code for that mission into that space and reads the script from that space. When you start another mission, the previous code is unloaded and the next one is loaded into the same space. Now we have everything to understand how duping works. Let's visualize everything to make it easier. Have you ever been in a situation where you have to read something, but you don't want to? So you are reading without paying any attention to the context. In the end, you don't remember anything you just read. The same thing happens here. That special location in the memory is your desk, and your job is reading everything that is put there. Somebody started a mission, and you are given the script of that mission. You start reading. You don't care about the context at all, but you are checking the current position, the local offset, very carefully. At some point you blink, and while your eyes are closed, somebody takes away the sheet of paper and puts another one instead. You open your eyes and continue reading from the same place where you left off. If you got lucky and ended up at the start of a new word, then everything is fine. Remember, you don't care about the context. But if you got unlucky and you have to start reading from the middle of a word, then your brain understands that something is wrong, and it crashes. Exactly the same thing happens in game. Your desk is a special space in the memory. Sheet of paper with text is a mission script that gets loaded into that space. The cursor position you are tracking is the local offset. Blinking is executing the wait command. Opening your eyes is coming back to processing the current script. And if you got lucky and start processing from the start of a new command, then most likely everything is going to be fine. If you got unlucky and start processing from the middle of a command, then there is a very high chance that the game won't be able to do it and will crash. I should say that there is a chance that the game won't crash, but the chance is very low, and I'm not going to explain how it works, because I think we have enough information for today. It is also worth mentioning that when you dupe, apart from the script that starts executing from the middle, you get another one that starts normally, from the beginning. After that, multiple scenarios are possible. Both instances can continue working. One of them can finish, or even both of them can finish. It really depends on the missions you used for duping. And this is how duping works. And now it should be easy to guess that instapassing is when you put the code of a mission in a way that the execution continues from the point that is responsible for passing that mission. Let me show you a real example. On the left we have Genka roundup, and the command that gives you percentage is set mission points, or originally player made progress. As we can see, it is located at local offset 1650, so we need a mission that has a wait command right before 1650. On the right we have evidence dash, and here's the wait command, and look, the next local offset is 1650, so this lines up perfectly. Therefore, if you start Genka roundup during evidence dash, you will instapass Genka roundup, because you'll start executing it from this line. When you find a promising combination like this, all you have to do is to understand which loop this wait command belongs to, which part of the mission that is. Usually it's done by reading lines before and after the wait command, and with enough context you get your answer. In this case, it is the main loop where you have to get evidence from the car. Fun fact about this instapass, it is not allowed in all missions speedrun, and that is because in the rules it says that you have to complete all of the missions that increment the mission passed counter in the stats. And the command that actually increments that counter is set latest mission passed, so it's right before the one that we execute. And that's why it's not allowed. If you want to find a valid instapass for that category, you'll have to find another mission that has a wait command right before 1640. Of course, you can also start executing from this line, or from this line, or even from that one. As we already know, commands are executed one by one, line by line, and we will eventually execute the one that gives you percentage. But what do you think will happen if we start executing from here? I already explained to you how return works, so will instapass work or not? Leave your answer in the comments, and most importantly, explain why you think so. This is your first challenge for today. The second challenge is, of course, find a brand new instapass in any GTA game. You might say, oh, all of the instapasses were found already, and you're gonna be wrong. During the last GTA Marathon I had a presentation where I found an instapass in GTA 3 Definitive Edition live. Right after that presentation, user WolfBloxer found multiple instapasses but in original GTA 3, so even old games still have something undiscovered. I of course will suggest you to look for instapasses in Definitive Edition, simply because how many different versions there are, but you can choose any game and any version you want. If you actually go for the second challenge, I have to say the following. I imagine that you find a combination that starts somewhere in between these two commands, for example. Let's say from 1648. You should still go and check the combination in game. Yes, I said that the chance of this working is low, but it is not zero, so you don't want to miss that chance. Go and check it, maybe it works. In the very start of the video I promised you to explain why instapassing doesn't mean getting the big mission pass text on the screen, and the answer is pretty simple. Here is the command that gives you the text, and as you can see, it's way before the one that gives you the percentage, so if we start executing from here, that one is obviously not executing. So we don't get text, we don't get music, we don't even get money, but who needs it when we get the percentage? Alright gamers, today we talked about what mission scripts are and how to read them, what duping is and how it works, and how it sometimes results in an instapass. I hope that all of the analogies that I made in this video and all of the visual stuff that I put on the screen really helped you to understand this complicated topic better. But if you still have any questions, don't be afraid to leave them in the comments. I will reply. With this video finally being out, we unlocked a lot of interesting topics. Remember, you can always suggest yours. In fact, 3 topics were already submitted by the viewers, so hurry up if you want to get in the last 2 slots. A poll for the next topic is going to appear on the community tab in roughly 3 days after this video is released. I will also link it in the pinned comment. Before I go, I'd like to thank everyone who filled in a little feedback form after my GTA Marathon presentation. Shoutouts to Goxy, Gudron, Sunny and Anakin Skywalker. Your inputs helped me to make this video better. I would also like to mention Nebnoob for promising me to watch the VOD and filling in the feedback form later, and actually never doing so. Hashtag TeamBlameNeb. And this is it for today. Thank you all for watching. If you enjoyed this video, leave a like, and if you don't want to miss the next episode, consider subscribing. My name is Waffle, see you the next time.
Where's the goddamn money? Where's the goddamn stuff? And where's my gun? Are you new action? You're making an idiot out of me, Tommy.